Okay, so today we are going to be talking about how to find the area of other polygons. So you can divide, the learning objective is to recognize when you can divide a polygon into triangles, and then that you can find the area of a regular polygon by dividing it into smaller shapes. Today's assignment really focuses on triangles in your workbook. I have assigned you other things that are going to allow you to mix it up and find the area of composite figures that have maybe a triangle and a rectangle together, or several rectangles, or a square and a triangle. So that you can learn how to decode that on your own and figure that out. Okay, so as you can see here, we've got what they're calling a kite shape here. And they've divided it, and you see all the measurements here. So the height of your top triangle is 3, and your base would be 8 for both the triangles, right? For the upper and lower triangle. And on your lower triangle, you have a base of 6. Okay? So to find the area of both of them, we're just going to use our formula. You need to become very familiar with this formula. It's not going away. You need to know how to use it in every form, right? Even when you're given the area and you're trying to go in reverse, is what I call it, going in reverse. Okay, so in this case, they're looking for the upper triangle first. So the base of, here we are, we've got our base of 8 and our height of 3. So multiplying those together will give you 24. Half of 24 is 12. So that's your top triangle, has an area of 24 centimeters. So same thing, bottom triangle, a base of 8, a height of 6, right? Can anyone guess, with a height that's twice as much as triangle A, what your area is going to be? Could it be possibly twice as much as the other one? Yes. So if you can recognize that, hey, wait, look, that's twice as much as that. So my area is going to be twice as much. You could save yourself some time by starting to make those connections. Okay, so then to find the area of the whole figure, 12 plus 24 gives me a height of 36 centimeters. 12 plus 24 is 36. So the total area of your kite is 36 centimeters squared. Okay, let's move on. So another way, they want you to find the area of a pentagon here. So a pentagon is just 5 triangles, right? You can see here that they find the center mark and they draw out to the points, which gives you a base and then a height to the center of the pentagon. So if you can find the area of this one triangle and then multiply it by 5, you can find the area of the whole pentagon. So let's see how they do that. So right here, you can see, using the same formula, area is equal to 1/2 of the base multiplied by the height. You have a base of 16 and a height of 11. So you multiply that out, 16 multiplied by 11, and then take half of that, and you come up with an area of 88 centimeters squared. Okay. What I would like to do here is I would take half of 16, and that would give you 8, and then 8 multiplied by 11 would give you your 88 centimeters squared. When my numbers are nice and even like that, or I can switch them around to an even number, I like to do that before I multiply these two. But when these two are kind of weird numbers, I just multiply them and then take half of that. So here's my 88 centimeters squared, but that's just for one triangle. That's for this one down here, right? Or this one here. They're all the same. They're all equivalent triangles. They're all the same size. Okay, so all you're going to do is multiply that 88 by 5, which gives you a total area for this pentagon of 440 centimeters squared. Okay, Um, she says the line segments from point for O, or the origin there, to each vertex, and vertex means corners, of the pentagon divided into 5 identical triangles. These triangles are isosceles triangles, right? Because both of the sides, they have 2 sides that are the same, and then their base. Okay, so same thing exists here. Same concept, dividing the hexagon into 6 pieces and finding the area of one of those pieces and then multiplying that by 6. So as you can see, your base here is 9.3, your height is 8. Okay, so just like the last one, find the center. Draw the lines out to the vertexes or the corners. Then that's going to give you your 6 pieces. You could do this on an octagon. You could do this on a nonagon. You could do this on a decagon. So, 9, 10, any of those, you can find the area using this method. Okay, so they have 1/2 of the base and the height. Once again, multiplying 9.3 by 8 and then dividing it by 2, and they come up with an area of 37.2 inches squared. Okay, so in your workbook, that's what you're going to do today. Now, you will discover, let me see if I can get out of this and get to your workbook. Sorry, wasn't planning on doing this, but I want to see here if we can, here, you're going to run into something that looks like this, right? Number 11 is one you're going to have to do. The idea is the same, right? Find the areas of the triangles and then multiply them. Okay, same thing here. You can find, you have the base and the height right here, drawing these triangles out to your vertexes. Let me see if I can just show you quickly what. It's not letting me. Control Shift 3. Nope, it's not letting me. Maybe it's because my thing's not open. Okay, so from here I would draw, and I'm really bad at drawing straight lines, and the line doesn't come with the, see, but you can see, you get the idea, right? I'm going to create triangles here, and wow, this is really bad today. Okay, ignore that, that's terrible. Okay, but you get the idea, right? You can do a much better job in your workbook, I guarantee. Okay,